Here's number 19 from the Larsen worksheet, or 8.9 worksheet, and it says f of x equals, if you read it, it says f of x equals negative 1 over x plus 1 squared, and they're saying that equals the derivative of 1 over 1 plus x, and they want you to find a series for this, so they're kind of giving you a clue on how to do it. So we want to find a series for this function, but we know that this function is actually the derivative of that. Remember, the derivative of 1 over x is negative 1 over x squared, so that's basically the same thing, because the chain rule wouldn't make a difference because the derivative of x plus 1 is just 1. So they're saying, well, how can we do this? Well, let's just take the derivative of this. And then we'll be able to work it out. And the reason why we have this is we can write this as a geometric series real easy, or as the function that has a geometric series. 1 over 1 minus negative x, and that's in my form a over 1 minus r, where a is 1 and r is negative x. So if I expand this function out, I know this function will be this geometric series, where I have my r is negative x, or negative 1 to the n, x to the n. So I'm just going to write this series as this, and then I'll take the derivative of it. So the negative 1 is not going to be affected, but this is going to be n times x to the n minus 1. So there's your series. Now remember, when we take the derivative, we have to up the index 1, okay? Because we're losing a term. Now, if we want to get this back with 0, we can change the index. Now, this is how you change. This is an easy way to remember how to change the index, because this is going to be kind of complicated if you're trying to think about this too much, how this index changes. So what we want is we want this to be 0. So how would I get 0? Well, if I subtracted 1 from both sides, I would have n minus 1 equals 0. So what I'm going to do is I'm going to let n minus 1 equals 0. Because that's what would result if I just move the 1 over here. And I'm going to call that m, so I don't get all mixed up. So if m equals n minus 1, then if I add 1, n would equal m plus 1. So let's go back and look at this series over here. And negative 1 to the n times x to the n minus 1. And then what I'm going to do is, if I, like I said, subtract 1, I would be n minus 1 equals 0. So I'll just subtract 1. Instead of writing n minus 1, I'll write m, because that's what m equals, n minus 1. And over here, instead of writing n equals m plus 1. And instead of writing n equals m plus 1. And instead of writing n minus 1 equals m. So I've written it like this. Okay? So I've changed my index, primarily going from 1 to infinity to 0 to infinity. Now, this index is just, or actually I should say the limits, index going from this. So, but this index, it's a dummy variable, so I can go back and call it n again. So I can call this n equals 0, minus 1 to the n plus 1, n plus 1, x to the n. Now you can see the difference here. But to come up with that by kind of doing it intuitively, a lot of people have trouble with that. Well, I mean, am I going to go back 1, then am I going to go forward 1? So you get all confused. This way, it makes it a little bit easier to do it. This is more analytically. Some people can do this intuitively, change indexes, but I'm not one of them. So if I write this down, it helps me keep everything straight. Otherwise, I'm going to mix up something. Okay? So that's a good application on changing the index to getting it back into 0 to an infinity.